So, continuing from where we stopped last time, that is looking into the objectives of condition survey. So, we said that objective may be simply estimation of characteristic strength, that is grade of concrete, or for for the purpose of checking the structural stability. So, we might take those values, do a complete analysis of the building and see whether it is safe or not. We will come to that sometime later on. Then sometime it could be simply find out the is it strength is adequate, so that I can undertake repair, rehabilitation or retrofitting work. And some other time for concrete, the objective may be simply judge the quality of the concrete. So, no quantitative, but is it okay, good concrete, bad concrete, poor concrete, etc. So, therefore, steps I said I was mentioning last class, I am just repeating them. First you must define the objective very clearly, then you must go for a visual inspection and document survey, right, and then set of tests, go to select them and complete the investigation. Once the investigation results are there, you do analysis, interpretation from the results, and obviously you come to a conclusion that if you are diagnosing something according to your objective. So, the conclusion should be either that the cause of distress is so and so, or it could be the strength is so much, FCK grade is so much, etc., etc. Then based on that you have your recommendation. So, this is all given in this flow chart sort of thing. So, if you see the top one, it would talk about first basically establish aims and information required, establish aims and information required. So, that corresponds to the objective actually. Then you do a document survey, preliminary site visit or visual survey, right, and then obviously at this stage you may have to discuss with the client and all involved, all organization involved, owner, client, whoever it is, if there is a dispute, all the parties, and agree to the criteria of interpretation what you would be using. Then you do a systematic visual inspection, followed by some survey, non-destructive testing, which will be comparative maybe with something else you might compare, and or calibrated assessment, either way. So, both can go on, and all this would be followed by localized investigation if required, because first you will do some kind of investigation to identify local place where the damage is maximum, may do or may not do depending upon the situation. So, if it happens to be that the local area you want to demarcate where the damage is maximum, then do some more tests there, might do coat tests, pull out test, several of them. And once you have done that, sometime the question comes that okay, everything is okay apparently, but you might do a load test to see everything is all right or not. This is also may be done after repair, right, may be done both, I might do even after repair depending upon the situation. So, all that I am doing right from here, that is interpretation criteria, systematic this information will all go into analysis, interpretation and finally reporting the results. Once that has been done, documentation of the results and also conclusions and whatever action is to be taken. So, that is the steps involved in visual survey, condition assessment in general. So, visual survey is carried out generally to have general idea about the structure, nature of the distress. Document survey means drawings, etc., last class as I mentioned, and also sometimes collect information from user, which the user in that case could be simply the person who's basically a kind of a security personnel or people who do some maintenance and operation works, maybe lift operators and so on. So, you can find out some information from them as well, and all this goes into your total making inferences related to why what exactly has happened and what has happened. So, what is the distress and when did it happen? Sometime particularly time of the first visual, first time of first detection of the defect, that may come from people like security personnel or liftmen or some similar people. So, that is what is the purpose of visual survey and document survey. Then I think I was talking about varieties of crack last class, right, and I just repeat them. Looking at the cracks or distresses, you should be able to, or generally one would be able to find what is the cause of it. For example, each type of distress manifests itself into a form of the different form of crack. For example, if it is a durability related crack, it will show up in a given manner. If it is a crack of the kind of, let us say, because of plastic shrinkage or drying shrinkage, they will manifest in different manner. So, based on that we can identify, that is what we are saying. So, like here I said ABC, I explained that ABC are plastic settlement cracks. This can occur sometime in within first 48 hours you will see, and if the bleeding is occurring. Now, for example, like someone might come to you and tell you there is a crack over the slab, like parking slab, which are very long slab, and supposing this is your parking slab, something like this, and long parking slab, and you might find cracks just quickly within 48 hours cracks, you might find cracks of this form matching with the reinforcement. So, you see cracks along this line, along this line, along this line. Now, this can happen again, for example, if the overdoses of plasticizer might result in excessive bleeding. So, this crack almost along the line of reinforcement as shown in this diagram top here. So, you can see this portion, this can be plastic settlement cracks. Now, this plastic settlement cracks will appear within first 48 hours or so quickly, because concrete would have subsided. As I said that here you have reinforcement, this is your concrete and reinforcement here, and there is a concrete, right. So, this would have concrete would have tried to settle like this. So, subsidence of the concrete, but this opposes the subsidence, therefore, you see cracks of this kind right on top of it, and they go along the bar, and therefore, something of this kind is plastic settlement cracks. You might see them over aggregates, sometime you will see them over haunches. So, but they will come quickly, or similarly where there is a column and slab junction. So, sometime you will see them very quickly. So, that is plastic settlement. Early shrinkage cracks are, as I said, DEF, they do come in thin sections, right, because the curing is not proper or something of this kind. They are of this form, normally random orientation, but generally depending upon the situation. For example, the shrinkage cracks that like shrinkage cracks can, particularly if you have long thin wall, and long thin wall, let us say something like this. Just I will have some example anyway. Supposing you have a long thin wall, thin wall of this form, thin, right, long thin wall, and without construction joint, sometime you might see vertical cracks, especially when summer time curing has not been done properly. So, you might see vertical cracks, and these cracks might be simply through and through at nearly equal space, because there is a construction joint, no construction joint. So, this would like to shrink, drying shrinkage, and drying shrinkage is a function of volume to surface area. When this ratio is small, the shrinkage occurs more, and this can result in, because restrained shrinkage, this can result no construction joint, long wall, no construction joint, there is a restraint in shrinkage, and this can show up cracks. So, these are in thin section cracks, you might see even cracks of this form, but if it is somewhere over the slabs, you might see something of this form, because it has dried off from the top, inside still moist relatively, and relative differential shrinkage might have caused cracking. So, is the case here, and F is D, F is also D is here, E is there, F is somewhere there. So, you can see that kind of crack especially between the restraints. So, one can from all information one can make good guess about this, diagnose this one. For example, you can find out this, the cracks are what we call, they are dead, they are not live, they do not extend beyond a point. So, and would have occurred, all come within first 5-6 months of the life, not beyond that, because early shrinkage cracks, they will come within not 48 hours, not during the plastic to hardening state, but during the hardening process, especially when curing is not proper, summer months in Delhi or northern India. Then thermal cracks you find in those elements where volume is large compared to surface area. So, you have differential shrinkage, differential contraction of the top, thermal contraction, inside is still warm, heat has not dissipated. So, these are the form of cracks which we might see in relatively thick structures. You might see vertical cracks or horizontal cracks depending upon the situation. Then crazing are actually fine mesh like cracks, like J and K shown here. J and K, the K, for example, this is crazing. It's generally not a problem, but it is also results from shrinkage, looks a bit ugly, like here it is shown, the looks pretty ugly, a little bit ugly, both on vertical and horizontal section you might see. Very fine cracks, not really harmful to that extent, but aesthetic is a problem. If it is a long term affair, after couple of years, you see cracks parallel to the reinforcement. This is plastic settlement is early, but this is reinforcement corrosion will come somewhat later, because it requires first the concrete might be still might be passive to start with, because concrete is alkaline, no chloride or something, but in the long run if it is get deep passivated and or some chloride comes from outside, in that case corrosion would initiate. So, there is a time for initiation followed by actual corrosion process, when product will expand, rust product occupies more volume than the original steel volume, and this will result in kind of cracking. Alkali aggregate reaction is also long term, you do not see them immediately, you see them much later, and they generally you will find cracks around the aggregate themselves. But important thing is that cracks are one thing, in addition to this certain other symptoms you can find out, and then you can diagnose. For example, in case of rebar corrosion, it would be rust staining or at least moisture marks, certain things you will see. So, you can put them two together to come out of the find out the cause. Similarly, and it will not happen early, that you understand. And similarly, if it is alkali aggregate reaction from your document survey or initial information from user, you can find out whether new aggregate was used, what is the source of the aggregate, was it tested, and then you can see when you look at the aggregate alkali aggregate reaction around the aggregate you will find white colored alkali silica gel. So, together with other things you can actually looking at the crack you can diagnose, right. So, this is what it is. Now, coming to test. Selection of suitable test could be straightforward. However, first if you look, visual survey tells you that what is the likely cause of the problem. First is objective. So, objective we know if it is no distress, no problem, but if there is some form of distress, then you visually observe, visual observation, the cracks, etc., and once you have done that, then once you have done that visual observation, then you have identified or made some good guess about the cause of the distress, then do the test specific to that particular one. So, the test that to be done will depend upon my objective. If the objective is to determine FCK, then I must do some amount of core test or some other test which is almost equally reliable. In fact, no other test can give you strength result or grade, if you want to get the grade more reliably than core. That is a direct test. Indirectly there are things like cut and pull out test, etc., which comes quite close to them, but it is the core through which you can get the in situ strength, through which you can get the in situ strength. So, if FCK is the requirement, then you must do core test. If FCK is not a requirement, just want to judge the quality of concrete, may not have to do core test, but you may have to do basically some other test. So, this is, it will depend upon your objective. First of all, suitable test will depend upon objective. Now, if you have seen the cracks and then you think that possibly rebar corrosion is a problem, in that case you got to do the corrosion related test. But if you do not see any corrosion cracks, it is not old concrete, why should you do corrosion test? You should not be doing. So, this will depend upon what is the objective, and then so it may be straightforward, but may not be straightforward also. Okay, some cases you might have options to do more than one test, right. Then you may have to do it, you have to like just for example, same test might give, I mean 2, 3 or more tests might give the same result, then which one do you choose? So, the issues that are involved are actually the cost of the test, reliability of the test. So, cost, reliability, these are the issues actually. So, we will see that actually how do we look into it. Number of test locations or number of tests anyway is based on cost, damage and accuracy. Some cases, for example, you do core test, you are at least partially damaging the concrete, and the cost of the test is important, but this cost will include a disruption cost also, because direct test, hiring an agency and getting the test done, okay, so you pay them something, therefore, that is the direct cost. But there is an indirect cost, because the space cannot be used by people. So, you might be incurring some losses, or at least functionally the building or the space actual structure is you cannot use. So, this is related to this is the cost aspect, direct as well as disruption cost, and more the number of tests you do, accuracy will increase. So, this is important, we will see more of it actually later on. Systematic variation of concrete properties work. Concrete properties vary systematically from top to bottom of structures. Therefore, within member or also surface, the strength will be, property will be worse, strength particularly will be worse near the surface. So, therefore, we know the typical type of variation. So, you should select the location of test considering all these kind of aspects. The other aspect is, you should not, supposing you are taking a core, do not take the core from the most vulnerable portion. If you take, for example, in a slab, if you try to take slab preferable, if you have a slab, right, say it is a 2A slab, let us say it is a 2A slab, and the failure plane, I mean basically something like this, crack would be something of this kind, etc., etc. Well, it would be better to avoid a core location like this, so that it does not lie on the expected expected what is called ill lines, or crack lines or fracture lines or failure planes and things like that. So, this is one aspect. So, you would possibly take from somewhere there, but then you have to see also damages where it has occurred. So, this is one aspect of it. Then other aspects of the locations are, as I said, the properties of concrete varies systematically from top to bottom. For example, if I have a section like this, vertical section like this, now water cement ratio will be maximum here, maximum, and cement, because cement has a tendency to go down, cement, while water will have a tendency to go up, water will have a tendency to go up, water will have a tendency to go up, cement will have a tendency to come down. So, water cement ratio, water is minimum, cement is more here, it is minimum here. So, obviously, strength is likely to be more here, strength is likely to be more here, right, strength is likely to be more, strength, higher strength, strength is high here, strength, and it reduces as we go up. So, strength will be likely to be least here. So, strength varies systematically from bottom to top. Similarly, strength at the surface will be lower compared to core. Core is better, core concrete is better, core concrete is better. So, while selecting location, you cannot in columns, you should not take all the locations, all the testing location to be top of the column or bottom of the column, then you are biasing them. So, either randomized or depending upon what is your requirement. I will come to that again maybe sometime more if I am talking of a case study. So, that is what it is. Now, we will come back to this location, some related to the formula related to number of tests and the function of error, we will come to that, but let us look at a little bit more on the first part, that is your visual survey, right. So, first identify, purpose of this is to identify the type of defect and area covered. Then you can actually start devise a kind of damage classification criteria. This can be done, and this is done for many structures. For recording purpose you can do that. So, something like this, for example, you can talk in terms of severity, extent and description of what has happened, and then you codify it. So, that recording becomes easier, right. Now, as you can see, it is something like anticipated state matrix we talked about. So, here also we are doing something similar. Now, severity, no surface cracks, then severity is none, there is no question of extent, and obviously the code you will put it in your. So, when you do a visual survey of a structure, you can do it like this, something like this. For example, you can write the in the tabular form, right here this column, serial number, then element description, then you might even put a photograph if you like, and then put the code. So, somewhere you can you can devise your own sort of classification and put a code. Maybe I have some examples I will show you. So, if you see no surface crack in a given element, put the severity none, small severity none, and extent is not there, and code is N1, or simply put the code, because this is already available to you. So, element and the code you will be writing. Then if it is small scale cracking or rusting you have seen, because this is related to cracking and rusting, this can be there for all other type of distresses as well. So, each table state matrix are there for every type of distress or every type of defect you are likely to encounter, even for let us say plastic shrinkage cracks. So, this is for cracking and rusting, one can have something for plastic shrinkage cracks, right. So, similarly, if it is a small crack, one or two localized in one local place, rusting with some cracks parallel to the one direction found locally in single element less than 50% of the area under study. In case of cracking and rusting, I might call it local. So, severity is small, this is local, and this is 1. If it is general over a larger space, then I can call it SG1. So, this was N1 and this is SG1, then this is ML1. So, now 1 stands for cracking and rusting. You can have others, for example, plastic shrinkage you might give some other coding name. Similarly, if you come to large one, lot of actually cracks. So, severity is large and it is local, rusting with extensive crack parallel to river in both direction, and in a single element less than 15% of the area. So, this is local, and if it is general, then it will be rusting with extensive cracks parallel to river in both direction distributed all over the area under study. That may be a slab or something like that. Then you put it as large general 1. So, one can use such kind of state matrix, description, etc., and then codify them. So, the inspector who is supposed to look at it, he just puts for against each element puts the code, which can be later on used for analysis, right. For example, this case rusting and cracking, a huge spalling. So, this will fall into the category of actually the last one, LG1, large general all over the area 1, and this is very much there in this you will find in many places actually, many places you might find this. So, one can do this kind of thing. I have some possibly I have some case studies, I will look into it. Then look into some of those. So, one aspect that I am saying that you can use anticipated state matrix, and these are available for one can generate them or are available for most of the types of defects or distresses you are likely to find. Then let us look at a little bit on intrinsic cracks. In case of intrinsic cracks, basically you can have cases like A, B, C. Say long walls without construction joints, nominal mix using accelerators and water reducing agent, manual volumetric batching, etc., section thickness is this much, crack description, vertical cracks extends through the full cross section wide. So, this is an example of an type A crack is the shrinkage type of cracks, it is 125 etc., long walls without construction joint, vertical cracks. So, this is kind of examples of intrinsic cracks. This is again shrinkage. This is again a case of same intrinsic crack cases. There are 3 cases shown for intrinsic cracks, cases A, cases B and cases C. In the first case here, these are 3 case studies actually, I will just show you photographs for better understanding. So, long walls without construction joint, second one was long walls without construction joint, this one also. Third one is segments of concrete ring used for precast tunnel lining. So, underground tunnel lining, precast tunnel lining the cracks. So, 3 cases we are discussing. The concrete mix was, this information was available, documents information from people or document. It was M20 grade, this is a pumpable M25 grade and this is a M45 grade. Now, this were done by and large using accelerators and water reducing agent, and manual and volumetric batching was used here largely. So, it is a almost non-engineered construction, manual and water curing, intermittent, not really proper curing as well, and the section thickness is 250 mm in the bottom and 150. So, it is a thin section as you can see, and observation was vertical cracks extend through the full cross section, right, wide at top and extend 125 to 175 mm from top surface of the of the foundation. So, from the bottom almost up to the top, about just about 125 to 175 mm from the bottom, no cracks because thickness becomes more there. Then the second one, manual water curing. Curing you see is manual here, both these cases, but this was a pumpable mix, right, and same again no construction joint, and intermittent curing with Hessian for 7 days. Here it was without Hessian, and then thickness is a 750 mm at the bottom and 475 mm at the top, and again same vertical cracks through the full cross section wide at top and extend about 1 to 1.5 meter from the top. Now, this case you see, this is a good concrete M45 grade of concrete, fully mechanized construction with batching plant, transported with agitator trucks and in the casting yard. So, curing is in the casting yard, but there was a little bit of problem with the curing, cured with inappropriate curing compound. Now, curing compounds are one which are applied on the surface. So, when you apply them on the surface, they stop the evaporation of water. So, retains the originally original water, mixed water, and self desiccation would occur, but essentially no evaporation losses would be there. Now, if you do not use, and then they peel off, once the concrete dries off sufficiently, they peel off from the surface. Now, if you have not used a proper kind of curing admixture, curing compound at the surface, and it peeled off early, then it would not stop the evaporation, and this can happen if depending upon the type of curing compound you are using. If it is wax based and it melts in at ambient temperature, then it will peel off much earlier. So, which can happen, for example, in cold countries you might be used to you might use a particular type of curing compound which may not be suitable for exposed concrete in India or tropical countries. So, therefore, this was the case here actually, reported peeled off too early, and as a result curing was improper. Section thickness was 280 mm, thin section again, curved segments approximately 3.6 millimeter long and 1.2 millimeter wide. So, multiple parallel cracks on the convex surface, we will show it, so we will see that, extending nearly through full thickness and exceeding through the full width. So, this was the case, these are 3 cases we are looking at early cracks, some diagnosis, right. And there are 3 more cases which we will discuss one after another. This case D is of precast linear element of folded plate for factory building roof, and you see the 50 millimeter was the thickness of the plates. These are steam cured M40 grade of concrete mechanized with batching plant. Multiple cracks at different orientations were seen. Okay. Actually, here the thickness was a major problem. Then these are precast plate elements for wall panels of factory building. These are plate element, this was linear element, line element like beam or column sort of thing, and this is M25 grade concrete mechanized with batching plant. Curing condition was not known. So, it was expected that they will follow IS 455, and thickness again of the plate is very small. So, multiple cracks at different orientation. Of course, the crack did not penetrate deep into it. Then circular cast in situ beam, 18th floor of a multi-storied building, M25 grade of concrete, and this was also mechanized. Curing conditions are not known, 40 mm deep beam, vertical cracks on both faces. So not enough, although width was not really enough. So, these are the kind of cases one can come across, right.